My dear boys, hope all of you are well. This is your physics teacher, Sajib Bishas. Uh, in our class, we were continuing our chapter 14, but this chapter is not so important. So we are going to our revision work. Our very important chapter is current electricity. So I am going to revise this chapter in this current situation. Dear boys, please help me for taking classes and trying to show your class timely, regularly, and ask me question by this channel. I will try my best to keep giving you answer as well. So we are going to starting our revision work, and this is our chapter is chapter 11. The name of our chapter is current electricity, and this is your physics teacher Sajib Bishas, lecturer Department of Physics, St. Gregory's High School and College. So dear boys, I think all of you are well and you are staying at home and you are in safe. So let's start our chapter current electricity. For current electricity, now we will know about current. What is current? Or definition of current. The, the current is a quantity of charge Q if the quantity of charge Q flows in time t, then we can write current as I equal to Q by T, or we can write the charge per unit time is called current, and the unit of current is ampere. Ampere is denoted by A. Okay. Now ampere is also equal to coulomb per second. Now is question how it is. We know that the unit of charge is coulomb, and the unit of time is the unit of time is second. Second is denoted by s, so we can write coulomb per second, and the coulomb per second is called ampere. If by definition of ampere is if 1 coulomb charge is flows through a conductor with 1 second, and by 1 second or per 1 second, then the amount of current is called 1 ampere. Okay, this is the law of current, I equal to Q by T. Now the Ampere's law na. Ohm's law. Ohm's law. Ohm's law is defined as at constant temperature. The condition of this law is temperature must be constant. At constant temperature, the potential difference between two points of a conductor is directly proportional to the flow of current. Okay? Okay. I'm repeating the definition. At constant temperature, at constant temperature, the potential difference between two point of a conductor is directly proportional to the flow of electric current. By the definition, we can write, if we denote potential difference as V and current as I, then according to this law we can write V is proportional to I. Then we can write V equal to IR. Here R is a constant. The name of this constant is called resistance. The name of this constant is called resistance. The unit of resistance, or we can write from this formula. We can write I equal to V by R, or also we can write R equal to V by I. Okay, আচ্ছা, okay. The unit of potential difference is denoted by V, and the unit of potential difference is V, volt. The unit of current is ampere, as mentioned before, and the unit of resistance is ohm. Okay, this is the law of ohms. Okay, now we will discuss about the law of resistance. We have two laws of resistance. One is the law of length. The law of length is denoted by, the topic is laws of resistance. We have two laws. One is law of length. Law of length. Okay. At constant temperature and constant cross-sectional area. At constant temperature and constant cross-sectional area, the resistance is directly proportional to the length of the conductor or length of the wire. Okay, acha. So okay, we can write resistance as R. R is directly proportional to the length of the wire. I'm repeating, at constant temperature and on constant cross-sectional area, the resistance is directly proportional to the length of the wire or length of the conductor. Okay, and then the second law, the name of the second law is law of cross-sectional area. Law of cross-sectional area. The law of cross-sectional area is at constant temperature and constant length. At constant temperature and constant length, the resistance is inversely proportional to the cross-sectional area. Inversely proportional to the cross-sectional area of the conductor. The resistance is directly proportional to the inversely proportional to the cross-sectional area of the conductor. Okay, and this is the two law of resistance. Resistance is depends on four things. One is the length. If length is increased, then resistance will also be increased, and if length is decreased, then resistance will also decrease. If the cross-sectional area though the cross-sectional area is inversely proportional to the resistance, then we can say that if the cross-sectional area is increased, then the resistance of the conductor will be decreased. And if the cross-sectional area will be decreased, then if the cross-sectional area is increased, then resistance will be decreased. Or if the cross-sectional area is decreased, then resistance of the conductor will be increased. Okay. Now, the specific resistance. Specific resistance. At from laws of resistance, we can see that the resistance is directly proportional to the length of the wire and inversely proportional to the cross-sectional area of the wire or conductor. If we combine these two laws, then we can write R is proportional to L by A, or we can write R equal to rho into L by A. Here rho is also a proportionality constant, and the name of this constant is the specific resistance. Now we will define the specific resistance according to this equation. Okay, let's see how we can define the specific resistance. We get R equal to rho L by A. Then we can write for specific resistance rho equal to R A by L. This is the formula for a specific resistance. By this resistance, we can define a specific resistance as if the cross-sectional area is 1 unit and the length is also 1 unit, then we can write rho equal to R. Now the definition of this specific resistance is at particular temperature. Here temperature is also important and temperature must be constant. Okay, then we can define at a particular temperature the resistance of a conductor. At particular temperature the resistance of a conductor of unit length and unit cross sectional area is called the specific resistance. Okay, I am repeating the definition again. At a particular temperature, the resistance of a conductor of unit length and unit cross sectional area is called unit length, and the resistance of a unit cross sectional area and unit length is called the specific resistance. Okay. And this is the law of our formula of specific resistance. Okay, next the combination of resistance. Next topic is the combination of resistance. We have two types of combination of resistance. One is the series combination, and another is parallel combination. One is series combination and another is parallel combination. Okay, Then we will discuss about series combination. Why we will call this type of series combination, we will see later. Now the topic is series combination. The definition of series combination is like that: if the resistance are connected one after another, if the resistances are connected one after another, then the combination is called series combination. Okay, let's see a configuration of a series combination. We will discuss this series combination with three resistances. If the resistance R1, R2, and R3 are connected one after another, this word is very very important. Connected one after another. If the starting point of the resistance one is R1 is A and the ending point is B, then the resistance then the starting point of the second resistance will be B. If the ending point of the resistance 2 is C, then the starting point of resistance R3 will be C. Okay, and the ending point is D. And here we will use a power supply, is called EMF, is denoted by E, and current is, we know that current is always passes through from the positive side of the battery. And you will see that the current and of different resistance, the current of R1, R2, R3 will be the same. The current of R1, R2, R3 will be same. The current of R1, R2, R3 will be same. And this type of combination is called series combination. And the equivalent resistance, we can write the equivalent resistance as R is equal to R1 plus R2 plus R3. We use three resistance, so this formula will be that. If we use the infinite type of resistance, then we can write that Rs equal to Rs means the equivalent resistance of a series combination. Then for infinite number of resistance, we can write R1 plus R2 plus R3 plus Rn. Infinite or n number of resistance, we can write Rn. Okay, this is called the series combination. Now we will discuss about parallel combination. Now I am trying to see you a parallel combination of three resistance, parallel combination. R1, R2, R3. This is the electromotive force, and we know that the current passes through from the positive side of a electromotive force or battery I. But in this point, we can see that for all of the resistance, the starting point are in a common point, suppose A, and The ending point are in another common point, suppose B. So this type of combination is called parallel combination, and for this combination the currents are divided according the currents are divided according to the resistance. The currents are divided according to the resistance. This type of resistance, this type of combination is called parallel combination, and the formula for parallel combination is 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. For n number of resistance, we can write 1 by Rp equal to 1 by R1 plus 1 by R2 plus up to plus 1 by Rn. This formula is called the equivalent resistance of parallel combination. This formula is called the equivalent resistance of parallel combination. All of these are the formula for our first lecture. We will solve a mathematical problem using this formula. Until then, thanks a lot.